Another one, the second one that I've picked out, again a very old one, 1989, but it serves our purposes for showing, for getting values of k. So a cyclist is freewheeling on a straight level road. He experiences a retardation which is proportional to the square of the speed. So again, his retardation is minus a. It's proportional to the square of the speed, so it's proportional to v squared. His speed is reduced from 6 to 3. So v is going from 6 to 3, in a distance of 35 metres, 0 to 35. Show that the average speed during this period is 6 times the ln of 2. Okay, so we have a starting equation. To get average speed, now average speed is total distance divided by total time. So I have the total distance, it's 35 metres, so I'm going to have to find how long it takes to do that. So I'm going to get another set of limits in here. Time going from 0, starting time 0 down to t. So your job again is to find t. Right, so we'll start and we'll get rid of that proportionality sign. So this will become minus a is equal to k times v squared. Find k using v and s. Okay, so I'm going to change this to minus v dv ds is equal to k v squared. I'm going to separate the variables. So again, this will become minus 1 over v dv is equal to k times ds. I'm going to put in integral signs and I'm going to put in limits. So v is going from 6 to 3 and my s is going from 0 to 35. Integrate this side here and it becomes minus the ln of v is equal to k times s on that side, and again I'm using 6 to 3, 0 to 35. So when I work all this out, this becomes minus, I'll take the minus out there, the ln of 6 minus the ln of 3 is equal to k from 0 to minus 35. So this, of course, will become the ln of 2. So this will be minus the ln of 2, because I'm going to divide them because I'm subtracting the logs, is equal to minus 35k. So k is equal to the ln of 2 over 35. Okay, so that's the first part. Now, I'm going to put that k then back into this equation. So it's t ultimately I'm looking for. So I'm going to now go back to the beginning. I'm going to take minus a is equal to k times v squared. I leave k as it is for a minute because it's a kind of a messy value. So I leave k and put it in at the end. I'm going to change this because I'm looking for time. I'm going to change this to dv dt. So minus dv dt is equal to kv squared. Separate the variables, minus 1 over v squared dv is equal to k times dt. Integrate both sides, that k is a constant. So this is going to be going from 6 to 3 and my t from 0 to t. So I'll work this out. This, remember, is v to the minus 2 dv, and when I work all that out, it's minus outside the integral, minus 1 over v is equal to k times t, and of course those limits are going from 6 to 3 and 0 to t. So this will become minus and minus will give me a plus, so this will now be 1 over 6 minus 1 over 3 is equal to k into 0 minus t. So this will be minus 1/6 is equal to minus kt. So now I have a value for t. It's 1 over 6 times k. I'll put in for k here now. So 1 over 6 times k, and k, remember, is the ln of 2 over 35. That's equal to t. I'll flip this over and give me 35 over 6 times the ln of 2 is equal to t. So that's how long it takes to go 35 metres. Right, question asked me for average speed up here. So the average speed will be the total distance, which is 35, over the total time, which is 35 over 6 times the ln of 2. Remember, working this fella out, this is 35 over 1 by 6 times the ln of 2 over 35. So I'm flipping this fraction, so this becomes 6 times the ln of 2 is your average speed, and that's what I was asked to find.